the hub is called the Erlangen Hub because most of you know Erlangen is a city in Germany. So to answer this question, we need to go back in history by more than 2000 years to ancient Greece, where geometry was born, or at least was first formulated in a rigorous way by Euclid, and it survived in this form for more than 2000 years, and it's probably still taught at school. And in the beginning of the 19th century came for the first time the realization that you can construct other types of geometry that do not rely on the assumptions of Euclidean geometry, in particular the one about parallel lines, in a self-consistent way. And this created an entire new zoo of different geometries that towards the second half of the century made this field very problematic or even toxic in some way. So there was not even an agreement how one defines a geometry. So a young guy called Felix Klein was only 23 years old that got appointed as a professor at the University of Erlangen in Bavaria in Germany, was asked to give an inaugural lecture about his future research at that place, which he actually never gave. He gave a talk about mathematical education, but he published a small booklet that entered the history of mathematics as the Erlangen program. And in this booklet, he proposed a revolutionary, radically new idea of how to approach geometry, basically considering properties of geometric shapes that remain unchanged or invariant when they are subjected to a transformation by a mathematical object called a group. So this created, first of all, order and hierarchy in the world of geometries. It allowed to integrate some of the new ideas that appeared in the 19th century, so creating non-Euclidean or Riemannian geometries. But it also had in some sort of philosophical or ideological impact on mathematics, so the follow-up ideas that abstracted it further, like category theory, so that's the more or less the language of modern mathematics, can be directly traced to the Erlangen program. And probably the biggest impact in science was in physics, where in the beginning already of the 20th century came for the first time the realization that the laws of physics itself, or the laws of the universe, can be derived from the first principles of symmetry and this idea of invariance and transformations. So under some iterations, these ideas have become what we nowadays call the standard theory, and this has survived the test of time, and this is the physics that we currently know. So what does it have to do with machine learning and artificial intelligence? Is also that in this field, the idea that you can derive different neural network architectures from first principles, even though it has been explored in some ways quite early on in the field, it is fair to say that it's only in the recent years, probably less than 10 years, these ideas have become standard and they have led to breakthroughs. So the ability to design geometric architectures that address in a proper way symmetries, for example, that you have in physical systems and problems that you encounter, for example, in biology or in chemistry, have been really useful and successful. And probably the biggest breakthrough was DeepMind's AlphaFold, that at least in part relies on these ideas that got its developers the Nobel Prize in Chemistry in 2024. So Erlangen Hub builds on this idea, the idea that you can take abstract ideas from mathematics and develop new concepts, new learning architectures and new approaches to artificial intelligence, relying on these tools, very powerful tools that have been around in different fields of mathematics for quite a while.